Hello, everyone. So, we're going to go ahead and get started today with the lesson 2 because we didn't get to finish it in class. So, we went through this in your books. All of this should be filled in. We went through this, and I think we stopped here. Okay, so I'm going to start here. I think I advanced a little bit more in some of my classes rather than others. So if I did go through this with you, just go ahead and fast forward the video, or you could just keep watching as a little refresher. So this one, let me see. Let me see. Let me go up here. This one right here is page 654. So 655, 656, 657. So this should be in page 657. So go to your books on page 657, and we're going to go ahead and get started. So I want you to first highlight right here. A quadratic function is written in the form f of x, ax squared plus bx plus c, where a cannot equal 0. And this is called the general form, or sometimes we call it standard form. Okay, and also a quadratic written in factored form is written in the form like this. Okay, so that's really important. And the thing about factored form is that you can find the two x-intercepts, or sometimes there's going to be one x-intercept. Whenever these two are the same, that means that you only have one x-intercept. Whenever they're different, you have two x-intercepts. So the x-intercept are opposite sign of what's inside the parentheses. Okay, and if that doesn't make sense, it will in a little bit, I promise. We'll work some examples out. All right. So let's go ahead and start practicing. So I'm going to go down here, go to the next page. It says determine from the equation whether each quadratic function has an absolute maximum or an absolute minimum. Explain how you know. So I'm going to take some notes before we go ahead and start doing that. So general form, you already know what general form is from the last page that we just did, the stuff that I told you to highlight. Look back at that. General form, you can find two things from the general form. So you can figure out if it's going to be an absolute maximum or an absolute minimum by looking at your A. Okay, so if A is greater than 0, meaning if A is positive, if it's a number greater than 0, that means it's a positive number. Then this is going to be concave up. And when it's concave up, the curve is at the bottom. So this is going to be a minimum. Okay. If A was less than 0, then this means that this is going to be a negative number and is going to be concave down. So that means that the curve is at the top, making it a maximum. Okay, and then the other thing that you could tell from general form, just from looking at the equation, is the y-intercept. The y-intercept is always going to be the constant. Okay, if you don't know what constant is, the constant is the number that doesn't have the x next to it. It doesn't have x squared. It doesn't have x. It's just a number that's by itself. That's the constant. Okay, so it's gonna be 0, comma c, whatever c is. Okay, so that's for general form. Now let's do factored form. Whenever you have factored form, you can find two things as well. So again, if A is greater than 0, this is positive. And if that means it's going to be concave up. The curve is at the bottom, so this is a minimum. If A is less than 0, this means that this is negative and it's going to be concave down. And the curve is at the top, so that makes it a maximum. And then you can find the x-intercepts, okay? So this is what I was talking about whenever you do the opposite sign. So the x-intercept is going to be whatever is inside of the parentheses. So let's say we have x minus r1, x minus r2. You're going to take the opposite sign. So that was a minus r1. So what's the opposite of minus r1? Positive r1. So it's going to be r1, comma, 0. And then for this one, it was a negative r2. So the opposite of negative r2 is going to be positive r2, comma, 0. And then just make a little side note is the opposite sign. Opposite sign of numbers in parentheses. Okay, so let's go ahead and work out some examples and see what all of this means with numbers. Okay, so let's starting with A. We have, this is, first of all, you need to recognize, is this general or factor form? This is ax squared plus bx plus c, right? So this is general form. So that means that I'm going to look at this stuff. Okay, is it going to be a maximum or a minimum? Well, look at your A. The A, this is A, this is B, this is C. The A right here is a 2. This is a positive 2, right? If it's a positive 2, so A is 2, that means it's going to be concave up. The curve is at the bottom, so this is a absolute minimum. And what's the other information that we can gather from this? We can tell what the y-intercept is, right? Right here. Look at your C is -1. You have to make sure that it's not just 1. You have to bring the sign that's in front of that number as well. So this is -1. So the y-intercept is 0, -1. And we just finished part A. That's it for part A. Okay, now let's do part B. No, actually, no. You're going to do part B by yourself. I'm going to check this whenever I see you next time. Let's do D, because D is different, right? This is, whenever you see parentheses, this is factored form. What's your A? Again, your A is always going to be the number at the very beginning, okay? So for general form, it was 2. Right here is going to be this number right here. So A equals -0.009. That's a negative. Since it's negative, it's going to be concave down. The curve is at the top. So this is an absolute maximum. And then we can figure out what are the x-intercepts. So look inside of the parentheses. This is x plus 50. What's the opposite of positive 50? Negative 50, right? So this is going to be -50, 0. That's your first one. And what's the other one? The other one is x minus 250. What's the opposite of -250? Positive 250, 0. So that's how you do that. I'm going to let you do B, C, and E by yourself. Don't worry about F for now. We're going to probably do that one in class together. So that's how you do that. I don't want to make this video too long, so it's not nothing difficult to do. So if you need to rewind the video to understand it better, please be sure to do that. And if you really don't get it after doing that, then you can message me and I'll help you. All right, moving on. Whoops. Okay, a vertex of a parabola. So this is really important. I need you to highlight this. So let me switch to highlighter. The vertex of a parabola is the lowest or the highest point of the graph in the quadratic function. The axis of symmetry of the line, the axis of symmetry or the line of symmetry in parabola is vertical line that passes through the vertex and divides the parabola into mirror images. So you already know what symmetry is. Whenever you cut something in half, it needs to be the same on both sides. The vertex is identified as either the absolute max or the min. So the max and the min is really important because that lets you know what your vertex is, okay? So for example, right here, the vertex, where's the curve? The curve is right here. So this is my vertex. my vertex would be, what's the x value? I'm going to go down here, 25, comma, whatever this is, like 1,250, we're going to say, right? So that's what that would be. This is your vertex. What's the axis of symmetry? If I cut this in half, if I cut a line through it in half, I'm cutting through the x-axis, right? So the axis of symmetry is always going to be let me erase this real quick. Is always going to be x equals whatever your x value is for the vertex. So that's why the vertex, and this is a max, by the way. That's why identifying if it's a max or a min is really important, because it correlates with the vertex and it correlates also with the axis of symmetry. The axis of symmetry is always going to be x equals whatever the x value for your vertex is, okay? Whether that's a max or a min. Whatever the x value for the vertex is, that's your axis of symmetry. And you can tell because if I cut this graph in half, then it is symmetrical and it's crossing the x value here at 25 right here, okay? So I hope that was a good explanation. That's how you do that one, okay? That's how you find out what the vertex is and what's the axis of symmetry. All right, what other information can I gather from this? I can figure out what's the factored form, because or actually, you know what, we're not going to worry about that one for this one, because I want to make this video not too long, and I feel like I'm going to just get into the main points, and then if you have any questions after that, let me know. So we're not going to worry about finding the factored form of this graph. You'll have plenty of practice whenever you do your math for that. Okay. Ooh, whoops. How do I go? Oh my God, it's not letting me. Okay. I'm trying to go to the next page. It's not letting me. Okay, here we go. All right. This is another important thing that I needed to highlight. For a function in factored form, this is what the factored form is. The equation for the axis of symmetry is given by this. So if you don't have a graph and all they give you is an equation, you can find the axis of symmetry by using this equation. For a quadratic function in general form, you can use the axis of symmetry equation, which is negative x equals negative b over 2a. So let's go ahead and apply that. So we're going to do number 3 and we're going to do number 5. Okay, so number 3 says identify the axis of the graph of each situation from the getting started using the factored form of each equation. So we're gonna go. You're gonna have to flip back for some pages until you get to the getting started. Where's the getting started? Here we are, right here. All right, let's do some examples. So I want you to write down right here, factored form. The equation was x equals R1 plus R2 divided by 2. And then for general form is x equals negative b over 2a. Okay, so let's go ahead and apply this to these scenarios. So they give us both general form and factor form. Right here, the top one is general form because you have ax squared plus bx plus c. Now, you don't have a c here, right? This is plus 0. There's no c there. We don't write down the 0. So I'm just going to go ahead and erase that. But I just wanted to show you guys that that is a general form, even though it doesn't have a c. The c is just 0 here. And the bottom one is factored form. Okay, so let's start with the general form. Let's start with the top one. Okay, our equation was x equals negative b over 2a. So x equals negative b. What is my b? Put that in parentheses. This is a. and this is b. My b is 100 over 2a. What is my a? Again, put that in parentheses. My a is negative 2. Make sure you bring that negative 2 with it, okay? Now put this in a calculator. And you should get that this is, I believe, 25, right? 100 divided by 4. And you have 2 negatives, so that makes it a positive. So yeah, it'd be 25. But I was able to do that in my head, but I want you to do it in your calculator, please, or in decimals. So there you go. The axis of symmetry is 25. Let's see if we get the same thing whenever we do it in factored form. We should, because it doesn't change. Okay, only the equation and the formula changes, but the answer doesn't change. So for factored form, we have this r1 plus r2 divided by 2. So what is my r1? What's inside of this parentheses? S, just S. It doesn't have an r1, so this would just be 0, right? So 0 plus, right here I have negative 50. So 0 plus negative 50 divided by 2. Okay. Oh, wait. I'm sorry. That wasn't a negative 50. That is just actually, hold on. Let me check something real quick. Let's see. Sorry, guys. I'm trying to check something in the book real quick because I don't know if they want me to show that. Okay. So for this one, it would just be a positive 50. You don't have to bring the negative 50 with it, okay? It'd just be positive 50. Positive 50. So 50, 0 plus 50 is just 50. And 50 divided by 2 is 25. So you see we get the same thing. Now, if you have a graph, it's really convenient because if I cut this in half, if I find the vertex is right here. I cut through the vertex. I'm trying to do it as straight as I can. And it crosses right here. And that value is when x equals 25. Okay, so your vertex is 25, comma, 1,250. And you can tell that the x value is 25. Okay, so there's many different ways of figuring this out. I'm gonna let you guys practice this one. Okay, and then we can do one more together. Let's do ghost tour. Okay, so the top one, this time the top one is factored form. So remember, factored form is R1, so R1 was 10 plus R2, so plus 50, divided by 2. So that's 60 divided by 2, which is 30, okay? And then that was easy, right? Now let's do the general form. The bottom one is the general form. General form is negative b over 2a. So negative b, what is my b? This is a, this is b. B is 400 over 2a. What is my a? Negative 10. Make sure you bring that sign with it. So that's negative 400 divided by negative 20. So this is also going to be, actually, let me make sure I did that right. Let me make it my calculator real quick. 400 divided by 20. That's not right. Did I make a mistake? Yes, I did. Because this is a negative 50. Okay. So then this would be, this is going to be, actually, did I do that right? R1 plus R2 divided by 2. This is my R1. This is my R2. Divided by, yeah. So yeah, I did make a mistake. This is not 60. This should be 40. My bad. And then 40 40 divided by 2 is 20. And then right here, you get 20. And then if you cut through here, you get 20. So yeah, that's my bad, guys. Sorry, it's late. I'm making these videos kind of late. But yeah, so the axis of symmetry is x equals 20. Okay, so there's many ways you could do this. The easiest way is if you know what you can graph it and then just look at the vertex, look at the x value. This one was 20 comma like 9,000. So then the vertex, the x value of the vertex is always going to be your axis of symmetry. Okay. All right. I think we finished. Let me make sure. Describe how you can use the axis of symmetry to determine the order pair. Okay, yeah, that one we don't really have to write it down because we already showed how we can do it, right? Just look at the vertex and that's it. Look at the vertex. So we can put look for x value of vertex. And that lets you know that that's your axis of symmetry. So yeah, that's it. Hope you guys have a great rest of your weekend, and I'll see you guys next time. Hopefully you guys actually watch this video and take notes because we have a test next week. So all right, guys, have a good one. See y'all later.